Hello everybody, my name is Hello. Welcome to this video series where we're solving Codeforces problems in Python. We are doing the A to OJ ladder, and in this episode we are solving problem 248A, which is called cupboards. Okay, so again, this seems like a very long problem, but it is quite easy only. Let's just go ahead and try to understand what this problem is trying to say. So let's read through this question once before we attempt to solve it. What they're trying to say is, one foggy Stockholm morning, this guy called Carlson, he decided to snack on jam, okay, in his friend's house, okay. And fortunately for Carlson, there was nobody else there, so he was not going to be hungry, so he decided to eat some food in the house. So there are n wooden cupboards in this house, okay, and each cupboard has a hidden jam stocks, okay. So he began to fry greedily and then opening and closing the cupboards and grabbing all the jam inside each cupboard and eating it, okay. So once he has eaten all of that, all the jams are empty now. Now Carlson has had enough and he does not want to leave traces of his stay. So he does not want to tell that he was here and he was trying to eat the jam, okay, so that he doesn't let down his friend. Now and how do we achieve this? How does he not leave traces? First things first, each cupboard has two doors, okay. There's a left door and a right door. And we know this is how cupboards are. There's a cupboard like this, let's say, and there's one part here, one part here. This is the left door, this is the right door, okay. Now Carlson remembers that when he rushed to the kitchen, all the cupboards left doors were in the same position and the right doors were in the same position. Meaning, let's say there are 5 cupboards, okay, 5 cupboards. And let us consider, okay, a cupboard being opened as 0, like left being opened as 0, right being opened as 0, left being closed or right being closed as 1, okay. So if I open this, I have to draw this. So instead of that, just assume that this is an open cupboard, okay. So here left is open, okay. So this will be 1 state and this will be 0 state, okay. So let's assume initially all the lefts were 0 0 0 0, all the rights were 1 1 1 1, something like that, okay. So all of this was same, all of this was same. That's what we're trying to understand here, okay. And yeah, that's what we know. Carlson wants the doors to meet his condition as well as the time the family returns. So when the family returns, he wants all of the left doors to remain the same position, all of the right doors to remain the same position, okay. Okay, what else are we saying here? Carlson does not remember the position of all the left doors. He cannot remember the position of all the right doors, okay. Therefore, it does not matter to him what position will be all left doors or right doors, but it is important to leave all the left doors in the same position and the right doors in the same position, okay. So left doors may be closed, right doors may be closed, left doors may be open, right doors may be closed. That's up to us. So there are 4 different combinations. All left doors can be closed, all left doors can be open. It can be like this or like this, okay. These are the 4 combinations and all of the doors should be 0 or 1, okay. Now given, and this is the question, okay, so, and Carlson needs 1 second to open or close a door. He understands he has very little time, so he wants to know the minimum number of seconds where he is able to bring all the cupboard doors to the required position, okay. That is what we need to understand here. So how do we solve this? Look, let's take this case for example, okay, where we have, so that's the input is first you get n, which is the number of cupboards, and in each one line it will be followed by n line, and each line will give the orientation of the left door and the right door, okay. Now let's take this case. This is the current position 0 1 1 1 0 1, okay. So one thing you can keep in mind is, for this particular case right here, the right doors, you can say I can just keep all of the doors open, which is 1, okay. I just need to replace this door alone instead of replacing these 4 doors, correct. So that is more cost effective, and I need 1 second to do that. And this 1 second you can just forget. They just need to count how many changes you need to make, because one change takes 1 second of time. So I have 1 door which I'll change here. So this will become from 0, this will become 1, okay. Here let's say the number of zeros are 3, the number of ones are 2, which means it makes more sense for me to change this 1, okay, to 0. So that will take another 2 operations, so that will be 2, and totally it will take 3, and that will be that. So one other question you might ask is it necessary for one half of the door to be either 0 and other to be 1, or this will be 1 and this will be 0? That is also not required, okay. Instead of this being something like this, let us say this is also 1. Okay. In this particular case, obviously this will be the same thing. One change will happen. Instead of changing these two to 0, we'll change these two to 1, because now there are 3 1s and 2 zeros. The number of 1s is greater than the number of zeros, so we go ahead and change these two to 1. Okay, so in that case, all of the doors in the end will be 1 1 1 1 1. Okay, so there is no restriction of one thing should only be 0 or one thing should be only 1, something like that. Okay, and that's it. So how do we solve this in Python? Before we go ahead with the code, it's very simple. What we're going to do is something called a frequency histogram. Okay, if you guys don't know what a frequency histogram is, let me just go over the concept once. This is something like a dictionary. I hope you guys know what Python dictionaries are. Okay, and how you can create one of these and how they'll look like is for each. So for left doors, what we're going to do is the number of zeros, and we'll put one number. Okay, let's say there are, in this particular case, there were 2 zeros, comma, the number of ones will be 3. Okay, and similarly for right doors, we know that the number of ones are 4 and the number of zeros are what? 1. Okay, we are going to create something like this. We are going to say for every particular character, how many occurrences are there, and this is something called frequency histogram. To kind of visualize, I mean, already you know graphs, right? When you're doing there, when you count the frequency, those are histograms as well. We're going to do the same thing. Technically, this is not a histogram, this is something called a frequency distribution. Okay, but yeah, this is what we're going to be using in Python. How that code looks like, it's very simple. I'll let you know. Okay, and one more thing to keep in mind. How once we have this particular frequency histogram, what do we do next? Right, so see, the total number, total cupboards are given by what? N, correct? So we can find out the minimum element here. Okay, and we can say those many number of operations we need to make. Okay, so let's say there are 2 cupboards here, there are 3 cupboards here, I mean 3 doors there, 2 doors there. I need to change these 2 doors. I have to change that to fit this. That will be the minimum number of operations, right? So in one case, I am going to change the minimum, minimum occurrence, okay, element. Okay, similarly in right hand side also, I need to change this to 1, and this is the minimum occurrence element, right, which is lesser occurred. Okay, minimum occurrence element. So this here also will be the same thing. So we're going to check there and see what is changing, what is lower here, what is lower here, and change that particular value. Okay, and that how we'll do is we'll create something called total, and this will be 0 initially. We'll look at what is the least value here. We'll add that to least of n l plus, and do that same to the least of r. So that's it. That is how this works. Let us go ahead and see how this looks like in code. Okay, so let's first get the input n. Okay, then let's just declare 2 dictionaries. One for all the left doors counting the frequencies, one for all the right doors and counting their frequencies. So that will be something like left, and we can take this as, see, this is 0 state and there are 0 counts. This is the state and the counts. Okay, and then in one state there are 0 counts initially. Okay, similarly, let us just go ahead and declare this for right hand side as well. Okay, these are the initial counts. Okay, then we have to take obviously n lines of input. So that will be for I in range of n. We can go ahead and take this particular state of this cupboard. Okay, so that will be state of the cupboard, and we can take that something as a list of map of in comma input dot strip dot split. If you guys don't know what this is, I highly recommend you to watch the previous videos. I would have explained it there, but this basically takes a list of space separated integers. Okay, then we assign the left this particular value. Okay, so that will be that state of 0. Similarly, right will be state of 1, correct? And these 3 lines are actually not required. If you know, there's a feature in Python where if you know the number of elements and the elements are constant here, you can just automatically assign them to different variables. So how that will look like there is, instead of putting the state here, you can just go ahead and declare what is LFT and what is RGHT. Okay, right here. And we're just calling this different because this left and right are 2 dictionaries. So use this only when, so you can simplify your code, but use this only when you know the number of elements. We know always it's going to be two elements, so we can use this. Okay, Then what we'll do is we'll increase the counter for this particular element by 1 and right of RGHT by 1. Okay, so how that works is, in case it's a 0, it'll say left of 0, okay, which will be this particular value, increase that by 1. If it is 1, it'll say left of 1, and that will be here, and increase that by 1. Similarly for right. Okay, that's how a frequency distribution works. In case you don't know these values also, there's a different way of doing that. We'll probably see that in a different question. Okay, so once you get this, what do? Nothing. You go ahead and compare which is the minimum for each. Okay, which is lesser in each case. And how do you do that? Simple. If left of 0 is greater than left of 1, so let us just go ahead and declare a total so that we can go ahead and print our answer as well and initialize that to be 0. If left of 0 is greater than left of 1, that means we have to go ahead total plus equal to left of 1, because the minimum number of elements only we need to add as operations, correct? Else, what do? Total plus equal to left of 0. Okay, so you can kind of guess. Similarly, we can go ahead and do for right as well, because we have to check for both. So if right of 0 is greater than right of 1, we can go ahead and add total plus equal to right of 1. Else we can go total plus equal to right of 0. Okay, once we know all of this, we can just go ahead and print this total value, and that will be our answer. So go ahead and run. You can see this particular test case passed. We can go back and submit this code so that you guys know that this particular code works. So as you can see, the solution got accepted. That's it, guys. It's a very, very simple solution. I hope you guys understood how we're approaching this problem. If this video helped you, please hit that like button. If you guys have any questions, let me know down in the comments. I'll see you in another video. Until then, bye.